in this video we're going to revise periodicity and the periodic table, so things like group 2, group 7 and redox. And we're going to do this using past paper questions. This topic pack can be found using the link in the description below. So you'll need a periodic table for this question pack. The first question, which element has the highest melting point? So we need to remember that chlorine is diatomic, phosphorus goes round in 4s, and sulfur is made up of 8 sulfur atoms bonded together. So this one's going to have the lowest melting point, then this one, then this one. Smallest molecule, lowest melting point, least number of electrons, then this, then this. But anything that's a giant structure like silicon, silica, graphite, diamond, that will have the highest melting point because lots of strong covalent bonds have to be broken. What is the best explanation for the trend in boiling points down the halogens group? That's group 7. The forces that these molecules have, they're diatomic, is induced dipole-dipole forces or London forces. As we go down the group, we're getting an extra electron shell each time as we go down a period each time. More electrons means stronger induced dipoles and stronger London forces. So the answer is D. Next question, which statement explains why nitrogen has a larger first ionization energy than oxygen? So to figure this out, we need to look at the periodic table. So why does nitrogen have a larger first ionization energy than oxygen? So why is it more difficult to remove the outer electron from nitrogen compared to oxygen? If we think about the electron configuration of nitrogen, it's 3 across in the p block, and according to Hund's rule, that tells us that electrons fill p orbitals singly in a p subshell before they start pairing up. Then the nitrogen will have the least repulsion. So this is the arrangement of p electrons in the p subshell for nitrogen, whereas oxygen, it's 4 along in the p block. So it fills up the p orbitals singly first, and when it gets here, then it starts pairing up. So these electrons in this orbital, they're repelling. That means that it's slightly easier to remove an outer electron from oxygen compared to nitrogen because of the extra repulsion in the oxygen because of these paired p electrons. Question 6 is about formulae and charges on ions. So group 2 metals, they have a charge of 2+, they form 2+ ions, and group 15 or group 5 generally form 3- ions. So an example would be magnesium nitride, and that means that the formula of an ionic compound would be this one, C. Question 8, which sequence has elements in order of increase in first ionization energy? So we can look at the periodic table to help us out here. The first one says sodium is less than magnesium is less than aluminium. And through process of elimination, the correct answer is C. So aluminium is less than silicon, which is less than phosphorus. And that is because of increasing nuclear charge. So in other words, phosphorus has the highest ionization energy, then silicon, then aluminium. So the other 3 are not quite correct. Question 14, which statements for group 2 elements are correct? So the first one, the second ionization energy of magnesium is greater than the second ionization energy of calcium. So if we have a look where these are, yes, that's true. It will be harder to remove an electron or the second electron from magnesium compared to calcium because magnesium has less shells, so less shielding. A strontium ion contains a total of 6 electrons in s orbitals. Strontium's here. It has a total of 10 electrons in s orbitals because it's in the 5th period. The equation for the reaction of barium with water is this. That's not quite correct, there's a formula error. So for barium hydroxide, we need brackets around the hydroxide ion and a 2 outside the bracket because barium forms a 2+ ion, So we need 2 lots of this hydroxide, the oxygen and the hydrogen, to balance. Therefore, the correct answer is D. Element A is in period 3 of the periodic table, and we have the first 6 ionisation energies shown below. And it's asking us to identify element A. So we know it's in the 3rd row. And the next thing we need to look for is where the big jump is. So the biggest jump in these numbers, these ionisation energies, is here between the 4th and 5th ionisation energy. That tells us that we have 4 outer electrons, and then this big jump means the electron is being removed from an inner shell, a lot closer to the nucleus. So it takes a lot more energy to remove that one from the inner shell. Period 3, group 4, that is silicon. And the explanation, large jump between 4th and 5th ionisation energies, meaning 4 electrons in the outer shell. Next question is about group 7. So chlorine is used to kill bacteria. State one risk of using chlorine in drinking water. We can have either that it's toxic or that it forms carcinogenic compounds. And carcinogenic means cancer causing. The next question is about redox, and it says using oxidation numbers show which element has been oxidized and which has been reduced. So we've got chlorine in HCl on the left, and here each chlorine will be -1. On the right, chlorine is in its standard state, in its elemental form. There it will be 0, and here it will be -1 again. So the element that's been oxidized is chlorine. It's gone from -1 to 0. Whereas the element that's been reduced is the manganese. So here, the oxygen's contributing -4, so the manganese must be +4. Here, the chlorine's contributing -2, so the manganese must be +2 to balance. And reduced means a gain of electrons, so the oxidation number is decreasing. Oxidized means a loss of electrons, so the oxidation number is increasing. The next question, we have to write a balanced equation. It says when the firework ignites, potassium chlorate reacts with aluminium to form potassium chloride and aluminium oxide. Write the balanced equation. So we've got our potassium chlorate reacting with aluminium. We're forming potassium chloride and aluminium oxide, and it gives us all these formulae. The next thing we need to do is balance. So this one's quite strange. The first thing I did to balance was looking at the oxygens, which I don't normally do. So there's 4 on the left hand side, or there was before I balanced it, and there was 3 on the right. So we need to make a number that we can times 4 and 3 by. That's 12. So we're going to use the numbers 3 and 4 to balance to make 12 on both sides. Now we can look at our aluminiums. So we've got 8 on the right hand side, 4 times 2. We can put an 8 here on the left, and then we can balance the potassium. So we can put a 3 in front of the KCl and check our chlorines are balanced, which they are. Next question is about the trend in reactivity of the halogens. So this question is about halogen halide displacement, and we have to remember that a more reactive halogen will displace a less reactive halide from solution. And the reactivity trend in group 7 is most reactive at the top, going down to least reactive. And it says plan an experiment on a test tube scale that will show the trend in reactivity of the halogens. And we're given these solutions of halides as well. So we don't need to provide volumes or anything like that, or equipment. It's not asking us for that. We can just say generally mix a solution of the halogen and a solution of the halide. So for example, a solution of chlorine can be added to 2 aqueous solutions containing bromide and iodide ions. And then if the halogen added is more reactive than the halide, a reaction happens and a colour change is observed. And I've written where we get the marks here. So the first mark for saying we mix a solution of the halogen and the halide, we actually don't get any marks for this bit. I was just explaining it more for this video. And the rest of our marks come from the observations. So I've written the textbook page number as well, if you've got the AS Chemistry textbook for OCRA. So the observation with chlorine, if we're reacting chlorine, the halogen, with bromide ions, we will see an orange-yellow solution, and these will swap places. So chlorine plus bromide becomes bromine plus chloride, and then we balance because the halogen is diatomic, so we need two lots of the ions as well. With bromine, it will displace iodide ions and we'll see a violet purple solution. And with iodine's at the bottom, it's the least reactive. It won't displace anything, so no reaction for that one. And the last question is about qualitative analysis, and it's ion tests. So it's a problem-solving question, and it says B and C are ionic compounds of two different group 1 elements. The molar masses of B and C are both approximately 140 grams per mole. A student dissolves B and C in water in separate test tubes and analyses the solutions. The observations are shown below. So I've annotated the tests in the table to show the thought process. Addition of nitric acid and seeing bubbles or nothing, that is a test for carbonate. Barium chloride, that is a test for sulfate ions, and a positive result would be a white precipitate. Use this information and the observations to identify the formulae of B and C. So I'm going to talk about this bit first before I start looking at this. So I've said addition of HNO3 nitric acid and seeing bubbles is a positive test for a carbonate, whereas addition of barium chloride and seeing a white precipitate is a positive test for a sulfate. We know we've got a carbonate, we know we've got a sulfate, so I've worked out the molar mass of the sulfate and carbonate ions. Then I've subtracted that from 140 because it says the molar mass is about 140 for each compound. So I want to see what's left so I can figure out which group 1 metal it is. Then these ions are both 2 minus ions. So I know that whatever I get as the difference, I'll need to divide by 2 because there'll be 2 lots of that group 1 metal. So I came out with 40 for compound B, the one with the carbonate. That's close to potassium, so potassium carbonate. I came out with 22 for compound C, and that is close to sodium at 23, so sodium sulfate.